Okay, so here I have a vector from x goes from 0 to 1,000. So if I want the 30th percentile, this is the 30th percentile. If I want the 30th percentile, so I want the number in here, which has 30% of the scores or of the other numbers less than it. So obviously that's 300. So 300 is the 30th percentile. And usually it's not so obvious, but in this example it's very obvious, so it's kind of not so interesting. But it is obvious that it's the 30th percentile is 300. And the 84th percentile is also obvious. It's the 840th number, right? 840 has 84% of the numbers in this vector below it. So if we run this with these two, so x is the vector, and this is the percentiles we're interested in, then the 30th percentile, we say the 30th percentile score, or I say anyway, the 30th percentile score is 300, and the 84th percentile score is 840. So that's how this quantile score works. Now what we're going to do is we're going to run the quantile score on score. Now remember what score was. Actually, I did the other video, previous video in the morning, and now this is in the evening, so I forget what score is. But so here's z, and what was score? So we applied the mean to across the rows to this matrix, or is it a data frame? Data frame. So so we have a bunch of means here. In fact, if we check, we look at what score is, we have all the means. We have 10 means, as I recall. So that's what this score vector is. Now we're going to ask the quantile function to tell us what's the 80th percentile score, what's the 60th percentile score, what's the 40th percentile score, and the 20th. So we want to know from these numbers up here, what number has 80% of the data below it. Remember, that's going to be like the cutoff point for giving people an A. So, and we're also going to say what number has 60% of the data, and that's going to be the cutoff point for a B. And this is for a C, and this is for a D. So when we do it, we get the results. 74 is the cutoff point for an A. Now, there may not be a 74 here. That doesn't matter. It just means that if anything is below 74, it won't get an A. Okay, and 43 is the cutoff for B, and minus 35. Remember that we scaled these so that we have negative scores here, and here negative 8 is the cutoff for a D. Okay. Okay, so now we have this vector y. I just showed it to you. Here it is. This is y, the cutoff points. And now we need a way to assign the grades. So that's what we want to do here. So we're going to define a new variable within our roster. Remember, roster is our new data frame. We're going to define a new variable called grade, or a new column called grade. And we're going to assign A's to some of those, and B's to some of them, and so on. So let's try and understand this code as well. Now this is very typical R code, so you do need to understand it. So let's try and do that. So first of all right, so it's better to work from the inside out. So we have score. Now once again, what is score? Score is here. So these are the scores that we've assigned to each student. These are the numbers. And we want to translate them into letter grade. Now remember what y is. Y is this vector of cutoff points. So y1 is what? That's the cutoff point for an A. So if score is greater than the cutoff point, which is what? What is it? Let's check it. Here. So this is the cutoff, let's say 74.74. So if score is greater than that. Now, but you have to remember that score is a vector. It's the vector containing all of the scores for all of the students. So this is recycling, an example of recycling, right? This is just a single value, but we're comparing it with score, so we're in effect recycling. And so we're going to, and then remember, this is a conditional operator, or a Boolean operator. And so it's going to result in either true or false. So, in fact, to visualize it, let's just run it and see what we get. So here it is. And as I said, this is going to result in a Boolean vector, a vector of true and false. And whenever it's true, it means that score, or that student, should get an A. So this student should get an A, and this student should get an A. And the others won't get A's. So going back to here, we have that Boolean vector in here. Now remember, we talked about how this works. Whenever it's true, this assignment will be applied, and otherwise it won't. So I actually did it here. I just ran that piece of code here, and then I wanted to see what does this new variable called roster grade look like. And what you find is that, remember, this one was true and this one was true. So we get an A here and an A here, and the rest of them are still NA. In other words, it creates the grade vector, but basically all of them are NA, but some of them, by this statement, get assigned the value A, or the letter grade A. Okay, so then the next one is pretty straightforward, if you understand this one. So the next one is here. So what is that? Well, it's a little more than I thought. So what is this? So if it's grade, if score is less than y1, it seems like, do we need that? Yeah, we do need it, right? Because if we didn't have this in here, then those A's would get reassigned to B. So yeah, we need this in here as well. So if it's if score is less than y1 and greater than y2, remember y2 is the B cutoff, so we do need this. I didn't think we needed it, but we do. Then we assign B, and the next one we'll assign C, and the next one D, and the last one, if it's less than y4, we assign F. Okay, let's stop here and we'll continue. We still have to sort by last name and then by first name.